Hey guys, welcome back. In the previous lesson, we looked at MapReduce architecture with Job Tracker and Task Tracker in Hadoop version 1 or MRV1. We also looked at how failures are handled in MRV1. Let's now talk about the architecture in MRV2. To understand the need for a new architecture in Hadoop version 2, let's talk about the shortcomings of MapReduce architecture in Hadoop version 1. The very first problem with MRV1 architecture is that you have one node, which is the job tracker, doing a lot of stuff all by itself. It takes care of resource management, scheduling, and job coordination. Meaning, when job tracker receives a client request to execute a MapReduce job, it look up the information in the input split and find appropriate nodes to schedule the execution of mappers and reducers, and also does the job coordination. Plus, take care of failed executions and keep the client updated regarding the job progress. That's a lot of stuff for one node, and soon enough the job tracker will itself become a bottleneck, slowing the execution of MapReduce jobs in your cluster. The next important shortcoming with MRV1 is related to cluster utilization. With MapReduce 1, as we saw in the previous lesson, the number of map and reduce tasks that can be executed on a node is set at the cluster level during cluster configuration. This means even if a node has resources to handle more tasks, the job tracker is not allowed to execute mappers or reducers, which is more than the configured number, which leaves the cluster underutilized. This is like driving a Ferrari at 20 miles per hour on a deserted highway. Not good. So, those are the motivations behind re-engineering the architecture of MapReduce in MRV2. In MRV2, the MapReduce architecture is referred as YARN, which stands for Yet Another Resource Negotiator. To enable YARN, you have to set MapReduce.framework.name property to YARN in MapRed site.xml file. If this property is set to classic, it means the cluster will run on MRV1 architecture with job tracker and task tracker. With YARN, the very first thing you will notice is that you don't have to configure the number of mappers and reducers that are allowed to be executed on a node. Instead, as a client, you can request for a specific amount of memory for your mappers and reducers at runtime. This is a huge improvement over the architecture in MRV1, where you are constrained with predefined number of slots for mappers and reducers on a given node. Whereas with YARN, you can manage the cluster resources at the memory level. You can use mapreduce.map.memory.mb and mapreduce.reduce.memory.mb configuration properties to set the memory requirements for both mapper and reducer. But there are limits to how much memory you can request for it, and it is controlled by YARN scheduler capacity minimum allocation MB for minimum limit, and YARN scheduler capacity maximum allocation MB for the maximum amount of memory that can be requested by individual tasks. Next difference you will see with YARN is that the job tracker is replaced by another process called resource manager and application master. The task tracker is replaced by node manager. The resource manager is usually executed on a separate node, just like the job tracker. The node manager is run on all the data nodes, replacing the task trackers. The application master is executed on one of the node managers, just like a mapper or reducer. In YARN, the cluster resources are managed in terms of containers. A container is nothing but a logical placeholder with memory limits inside which the node manager will execute processes like application master, mappers, or reducers. As a client, when you request for a MapReduce execution, the resource manager receives the request and it creates a container in one of the node managers and will launch an application master process in the container. The resource manager then hands off the MapReduce coordination for that specific job to the application master. So if you have 10 MapReduce jobs running in your cluster, at a given time, you will have 10 application masters running in your cluster. As a client, when you request to execute a MapReduce job, you can also specify the amount of memory you would like to allocate for mapper and reducer using properties MapReduce map memory MB for mapper and MapReduce reduce memory MB for reducer. If you don't specify them, by default you will be allocated 1 GB for each mapper and 1 GB for each reducer. For example, let's say we submit a job which required 10 mappers and we set MapReduce map memory MB to 2 GB, then Application Master will request Resource Manager to allocate 10 containers with 2 GB each to execute the mappers. The Resource Manager will then look at the available cluster resources and assign 10 containers on different data nodes. The Application Manager then contacts the node managers on those specific nodes and will create those 10 containers. The mappers are now executed as a Java process inside those containers. The node managers are now tasked to monitor the progress of the mappers running in those containers and update the application master with the progress. Each MapReduce job in Yarn is managed by a dedicated application master as opposed to just one job tracker process in MapReduce 1 managing all the jobs in the cluster. And the job of the resource manager is just to allocate resources requested by the application master in terms of containers. That is it. The application master takes the responsibility of job coordination and update the progress back to the client. Now let's talk failures. When a mapper or reducer task fails, the node manager overseeing the task will see the failure and will notify the application master. The application master will then contact the resource manager and ask for a new container to kick off the failed mapper. So a map or a reduced task failure is not that critical. Whereas, let's say the application master failed. The application master and resource manager are always in constant communication, so when the application master fails, it will be recognized by the resource manager and the resource manager will start a new application master on another node. The application master is designed to recover nicely. So the mappers and reducers which were already completed will not be re-executed, which definitely saves time. Only the pending and the failed mappers or reducers will be re-executed. Finally, what if the node manager fails? The node managers are also in constant communication with the resource managers, and the resource managers will recognize the node manager failure and will make a note of it and will not allocate any new containers on the node manager, and it will also make arrangements to rerun any application master or map or reduce tasks which were being executed on the failed node manager. Failure of resource manager is very serious, since without that, no new containers can be launched. Although the existing applications will be executed without any issue since the job coordination is handled by the application master, as long as there is no need to allocate new containers. The resource manager is designed to save its state to a persistent storage so that the persistent storage can be used by the administrator to recover the resource manager. As long as the resource manager is down, no new containers can be created and the MapReduce execution in the cluster will suffer. And hence this is a much critical failure. But since the resource manager is not as overloaded as job tracker, the resource manager failure is less common when compared to the job tracker failure. If you want to find out where the resource manager is running in your cluster, look at yarn site.xml. In our cluster, you can find the yarn site.xml file under etc Hadoop conf. Yarn.resourcemanager.hostname tells us where the resource manager is running. You can also access the resource manager through Web UI. And the location of the Web UI is specified by the property yarn resource manager webapp.address. Let's look at the resource manager Web UI now. This is a very familiar screen for us. This URL is the URL we go to monitor our MapReduce jobs. When you click About, you will see information about the resource manager and its status and version. You will also see the number of applications that was executed on your cluster. Let's click on Applications. You will see a list of applications. In Yarn, everything is executed as an application. Our MapReduce job is also executed as an application. Yarn is designed in such a way that it can handle beyond just MapReduce jobs. That is, it is designed to handle applications which are distributed in nature and want to use Hadoop framework. So MapReduce is one such application types that Yarn can handle. Let's say you have a brilliant idea to develop a programming model just like MapReduce, which is distributed in nature, and you would like to use Hadoop. You can use Yarn for resource manager and application coordination because your new programming model will become another application type. When you click on the tracking history URL, you will find out from the heading of the page that it is a MapReduce job. And the application master for this application was executed on this node that is highlighted right here. Now let's check the mappers. As you can see, there were 2 mappers that was executed for this job. And you can even drill down and look at the attempts and where each mapper was executed. You can do the same for Reducer too. So to summarize, in this lesson, we saw the shortcoming of architecture in Hadoop version 1 and the need for the new architecture Yarn. We saw in detail how Resource Manager replaces Job Tracker and also how it delegates the responsibility to Application Master, offering a much more scalable architecture than MapReduce version 1. With that, let's wrap this lesson. See you in the next lesson.